Hello and welcome to In Simple Terms with Satish. Today we are talking about how smartwatches know you are sleeping. Let us start with the technology first. A smartwatch does not directly read sleep from the brain. It estimates sleep by combining signals such as motion, heart rate variability, oxygen trends, skin temperature, breathing patterns, time, and learned patterns. At first, it can sound like one clever feature, but the real story is a system of sensors, models, rules, feedback loops, and trade-offs that has to work in the real world, not only in a demo. Let us understand this with a simple everyday example. Imagine standing outside a house at night and guessing whether everyone is asleep. You cannot see their dreams. But you can notice the lights are off, the house is quiet, nobody is walking around, and the same pattern continues for hours. A smartwatch makes a similar inference from the wrist. It cannot see sleep directly, so it looks for clues. Now return to the actual technical concept. Under the hood, the stat has several parts. First, motion sensing, where accelerometers and gyroscopes detect stillness, tossing, and movement patterns. Second, heart signals, where optical sensors estimate pulse and changes in heart rate variability. Third, breathing and oxygen clues, where some devices track respiratory trends or blood oxygen estimates. Fourth, temperature trends, where small overnight changes may help identify routines and recovery patterns. Fifth, machine learning classification, where the device maps patterns into sleep, wake, and sometimes stage estimates. Sixth, personal baselines, where the same signal means more after the watch learns what is normal for one person. That list matters because modern technology is rarely one model or one app screen. It is usually a chain. Data has to be captured, interpreted, checked, acted on, and corrected when reality disagrees. For engineers, the useful idea is this. The practical pattern is sensor fusion with confidence. Combine weak signals, compare them to a baseline, explain uncertainty, and avoid pretending the model saw more than it did. The catch is uncertainty. A watch can confuse quiet reading with sleep, miss short wake-ups, or estimate stages differently from a medical sleep lab. The value is trend awareness, not perfect brain state measurement. This is why the topic matters for students and builders. The visible product may look simple, but the engineering work is in the hidden boundary conditions. What happens when the input is noisy? What happens when the user behaves unexpectedly? What happens when the system is confident but wrong? What gets logged, reviewed, updated, and rolled back? A good way to learn the topic is to sketch the pipeline. Draw the input signals on the left, the decision or prediction layer in the middle, the user-facing action on the right, and the failure modes underneath. That one diagram will teach more than memorizing the buzzword. The clear takeaway is this. Smartwatch sleep tracking is not mind reading. It is inference from wrist signals, timing, personal patterns, and probability. In simple terms, the magic is not the label. The magic is the system design underneath, and the discipline to know where the system works, where it fails, and how humans stay in the loop. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish. I will see you in the next episode. A useful way to test your understanding is to ask what the system knows directly and what it only guesses. The gap between measurement and inference is where many failures hide. Another useful question is who owns the decision when something goes wrong? The model, the sensor, the operator, the policy, or the product design behind wearable sleep tracking and sensor fusion. That is why good engineering explanations should include the happy path and the messy path. The messy path is usually where the real architecture becomes visible.